Now let's discuss what we call combinations of functions. The first of these four we have is a sum of functions, and that's given by f plus g of x equals f of x plus g of x. Exactly what the name indicates. We will sum the functions. A difference of functions is given by f minus g of x equals f of x minus g of x. Third, the product of functions is given by f times g of x. Most of the time we just use implied multiplication here, but f times g of x equals f of x times g of x. And a quotient of functions, f divided by g of x equals f of x divided by g of x, as long as g of x is not 0. The restriction that the denominator cannot be 0 still holds. It is still valid. Now let's work with one of these. Given that f of x equals x plus 3 and g of x equals x squared minus x, find f plus g of negative 5 if it exists. I'm going to first write this as f plus g of negative 5 equals f of negative 5 plus g of negative 5, because that is what it means by definition. Now on the side, I would like to figure out what f of negative 5 is. Well, because our function f of x is x plus 3, that would be negative 5 plus 3, or negative 2. So I'm going to replace this value, f of negative 5, with negative 2. That is one side note. Our next side note is g of negative 5. That would be negative 5 squared minus negative 5. So that would be 25. That would be plus 5, because of the two negatives, which would be 30. So negative 2 plus 30, which would be 28. So that is g, or f plus g of negative 5 is 28. Our next example says, given that f of x equals x squared minus 4x and g of x equals 2 minus x, find f minus g of x and the domain of that. And then also, part B, find f minus g of 3. So f minus g of x, let's do this. F minus g of x is equal to f of x minus g of x. Again, by definition. So that would be x squared minus 4x minus 2 minus x. So this is all my scratch work. That is my definition and my scratch work. Now if I combine some terms, that would be x squared. Now this would be negative 4x minus negative x. So that would be negative 4 plus x, or minus 3x. And then we have a minus 2 because of this term right here. So that is f minus g of x. Now the domain of that, because it is a polynomial, that is minus infinity to infinity. Now because we've already found f minus g of x, we can say that f minus g of 3 is x squared minus 3x minus 2. We're replacing that with 3. This would be 9 minus 9 minus 2. 9 minus 9 is 0, so that would be negative 2. Our next example, we have let f of x be x squared minus 6x, and g of x is 7 minus x. Find f times g of 8. So let's first just find what f times g of x is. That would be x squared minus 6x times 7 minus x. And if we do some distributing, we have 7x squared minus x cubed minus 42x plus 6x squared. Okay, combine these together, just double check that, multiply that again, 7 times x squared, 7x squared. X squared times minus x is minus x cubed. Negative 6x times 7 is negative 42x, and negative 6x minus x is plus x squared. Okay, perfect. Now, combining those, we get minus x cubed. We have a 7x squared and a 6x squared. That would be 13x squared, and then minus 42x. That's f times g of x. To find f times g of 8, I'll replace x with 8. So negative, parentheses, 8 cubed, plus 13 times 8 squared, minus 42 times 8. Now let's see if we can, I'm going to put that in a calculator and do that all in one step. Negative 8 cubed plus 13 times 8 squared minus 42 times 8 is minus 16. Given that f of x equals x squared minus 4 and g of x equals x minus 2, find g divided by f of x. Make sure to simplify completely, and then also determine the domain of the function. So what we can first do is take g of x divided by f of x. That is, by definition, g of x divided by f of x. That would be x minus 2 divided by x squared minus 4. Now, this reduces, actually, because the denominator factors into x plus 2 and x minus 2. It is a difference of squares. And the numerator is x minus 2. Now, these two x minus 2 factors form a 1, so that this simplifies to be 1 divided by x plus 2. So that's the simplified form of that. But now when we go to find the domain, what we want to remember is that we do not use the reduced form of that. We actually use the unsimplified form to determine the domain. All right, so we'll go back and say, actually, let's go ahead and sum that up. G of f of x equals 1 divided by x plus 2. But for our domain, what we'll do is determine what would make the denominator 0 in the unsimplified form. Well, that would mean where x squared minus 4 is equal to 0 is not included. Well, x squared minus 4, we know from our factoring, is x plus 2 and x minus 2. That's going to be 0 whenever x is negative 2 or x is positive 2. I'm going to write that as x is not equal to negative 2 or positive 2. In interval notation, that would be minus infinity to negative 2, close parentheses, union, open parentheses, minus 2, comma, positive 2, close parentheses, union, open parentheses, 2, comma, infinity, close parentheses. All parentheses because we definitely never include infinity, but we are not including negative 2 or positive 2. So this is our domain in interval notation, and this is our function. Our next example with these operations, we need to find f divided by g of x, the domain of f divided by g of x, and find f divided by g of 8. And our two functions, we have f of x equals x squared minus 4x, and g of x equals 7 minus x. So let's first find f divided by g. By definition, that is f of x divided by g of x. So x squared minus 4x divided by 7 minus x. And that is our function. That does not simplify. So for our domain, we have to note that x cannot be equal to 7 because 7 minus 7 would then be 0. That tells us what our domain is. Our domain begins at minus infinity as an interval all the way until 7. That's the only problem we have. Close parentheses, because we don't want to include that. Union, open parentheses, 7, comma, positive infinity. All real numbers except for positive 7 is our domain. Now we can take that function that we just found and evaluate it at 8. So we'll take x squared minus 4x divided by 7 minus x, replacing x with 8. So 8 squared minus 4 times 8 divided by 7 minus 8. That would be 64 minus 32, which is 32, divided by minus 1, so that f divided by g of 8 is equal to minus 32. Now for our last example of this type, let h of x equal x plus 6 and g of x equal the square root of x minus 6 as a quantity. First question is find h minus g of 10. And I would much prefer to find h minus g first. So this will be h of x minus g of x. All right. Well, h of x is x plus 6 minus the square root of x minus 6. Now there are no terms I can combine there, so let's evaluate this at 10. So this will be 10 plus 6 minus the square root of 10 minus 6. Well, this is 4, so the square root of 4 is 2. So we'll bring that down. So that would be 16 minus 2, or 14. That is the value we are after. Next, we want to find the domain of h divided by g of x. Separate functions. So h divided by g, well, that is going to be equal to x plus 6 as a numerator and the square root of x minus 6 as a denominator. Now we have two things at play here. One is that the denominator cannot be equal to 0. All right, so that means, set this over here, x minus 6, the square root of x minus 6 cannot be equal to 0, but also, because we have a radical, x minus 6 must be greater than or equal to 0. Those two things are at play. So the first of these occurs whenever x is equal to 6. So x cannot be equal to 6. Now the second restriction says that x must be greater than or equal to 6, because if we add 6 to both sides, so x must be greater than or equal to 6, but not equal to 6. So you put these two together, and that tells us that x can only be greater than 6, cannot be equal to. So that our domain begins at 6 and goes to infinity as an interval, and we have a parenthesis on 6 and infinity because it cannot be equal to 6.